Alright, hey everyone. Welcome into the next part. We're going to go through some polyatomic ions, and they're really just a continuation from the ionic compound worksheet that we talked about from before. So, just as a refresher, a reminder, for the warm-up, either state the name or write the formula for each ionic compound. So we have three that are down here, A, B, and C. I would like for you to take a second and just see if you can get either the formula for each one or to say the name if you're already given the formula. So if you're given symbols, write the name. If you're given the name, write the symbols. And so pause the video, give it a try, and come back when you're ready. Alright, so let's take a look. Two of them, starting off here, have symbols on them. Let's just kind of go right through the list, A to B to C. So in the first one, I've got Na3P. Na is sodium, and P is phosphorus, which we have to change that ending around. But I guess the biggest thing here is, does it need a Roman numeral? And so I would check with sodium and see that sodium only has one charge when I look at the table. It just has a 1+ charge. So I would just say that this is just sodium, and then instead of saying phosphorus, we have to change that ending to IDE, phosphide. Now, in the second one, I have a transition metal here. I have gold. And so if I look at the table, gold is number 79, and it can have a charge of +3 or +1. And in the brackets here, it's telling me that this has a 1+ charge. So if I know that gold has a 1+ charge, I'm going to run through my little strategy that I have here. I'm going to start with the symbol. I'm going to write the charge above it. And then I'm going to do the same thing with oxide. Remember, oxide is just oxygen. It has a 2- charge. I'm going to cross my charges, and I'm going to end up with Au2O. So, I eliminated the 1. I can't reduce it any further. Au2O would be my compound. It would be my formula for this. Now, in the last one, this is just tin, okay, Sn. And I have oxide, but then I have to check tin and see if it can have multiple charges. And so in this case, tin can have 2 charges. It can either be +4 or +2, and I don't know which one it is. So I'm going to put brackets here, and we're going to write the word oxide. And so how can I figure out what the charge that's going to be there for tin? Which charge would show up? So we know oxygen has a 2- charge, and we're going to use this idea of balancing, right? Positives balance out the negatives. So I have 2 separate oxygen atoms that are here, and I know for sure each one of them carries with it a -2 charge or a 2- charge. I want this to equal 0. So what does this one have to be in order for that to happen? In this case, I can see here that tin needs to be a 4+, because 2 times 2 gives me 4 negatives, right, 4 electrons, so I need 4, or a positive charge of 4, to cancel that out for this to make sense. So I need a tin 4 ion for this to work. So when I look at the table and I see it can have multiple charges, I really have to look and see, okay, what do I need to balance this out to be 0? And what I find is that I need that 4 ion to come out. So it'd be tin 4 oxide. Alright, so let's get started into polyatomic ions. So when we start to take a look at polyatomic ions, they're groups of nonmetals, so groups of atoms that tend to stay together, and they carry this overall ionic charge with them. So there's a couple different examples that are here. I've got NO3 that has a little minus beside it, that's nitrate. I have CO3 has a little minus beside it, that's carbonate, and ClO3 minus, which is called chlorate, and they all have this little 1- attached to them. So collectively, NO3 is going to want to take in an electron in order to be stable. CO3 is going to want to take in an electron in order to be stable. That's what those minus signs mean. So it's not just the oxygen, it's both things. They're sharing their electrons in order to have this overall charge. Notice the difference in the ending here. They all end in 8 in this case, whereas before, when we wrote them out, we had these endings "-ide" coming in. So "-ide" kind of matches up with our ionic compounds. And for the most part, what we're going to see here is we're going to have 8 ATE, or we're going to have 8 ITE show up in terms of the endings for some of these compounds. So a polyatomic ion really is just a group of nonmetals. It's kind of a second level of ionic compounds, and all they do is they just share an overall charge. So when these ions are combined with metals, they form polyatomic compounds. So all of these polyatomic ions, as I look at them, they're all nonmetals. So a polyatomic ion is a collection of nonmetals that share an overall charge. Typically negative, but not always. There are some exceptions that we can see. So when I combine them with metals, I get polyatomic compounds. So an ionic compound is just a metal and a nonmetal. A polyatomic compound is a metal and a group of nonmetals to balance out. So some examples here might be NaNO3, sodium nitrate, or NaCO3, where I have sodium carbonate. So notice that I'm not changing the ending when I write these out. When we did them before, for ionic compounds, I have to change the ending to IDE. But when we do polyatomic compounds, we just keep the same ending that's there. We don't change anything. So polyatomics is what you see is what you write. So where can we find these? On your periodic table, okay, on your version that you have, when you take a look in the middle part, you're going to see a little column. 3 columns, I guess, and it says polyatomic or table of common polyatomic icons. So right here, and then if we scroll down to enlarge this, this is where we see all of our polyatomic ions and their charges next to them. So you can see that really the vast majority of them are all negative charges. The only one that's the exception to that would be ammonium. It has a positive charge. So all of the other ones are going to have a metal combined with them. In the case of ammonium, I may have ammonium mixing in with a nonmetal, or I may have ammonium mixing in with another polyatomic ion in order to make their charge. So we treat them the exact same way that we do ionic compounds, because polyatomic compounds are ionic compounds. The difference is that poly really just means many, whereas ionic compounds, the way that we would know them, really are called monoatomic ionic compounds because they're singular. It's one metal and one nonmetal. But a polyatomic compound is one metal and a group of nonmetals. Or in the case of ammonium, it is a collection of nonmetals that could mix together with another nonmetal, or it could mix together with another polyatomic ion. So you'll have your periodic table for you on any quiz, test, exam, anything that you can reference. And so hopefully this list will come in handy when you're looking to find them. If you take a look at them, all of them have multiple nonmetals. And so that's kind of the idea between polyatomic ions, is that it has a collection of nonmetals that work together. So here are some steps. Let's take a look at sodium. So we have Na, and then we have SO4. So if we take a look at SO4 in our table on the top, SO4 is sulfate. And we can see that 2- on sulfate. So step 2, write the ionic charges. Okay, sodium we know has a 1+ charge. I can find that right on the table. And sulfate, if I go back to our chart for a second, I can see that sulfate right here has a 2- charge. So sulfate is going to want to take in 2 extra electrons in order to be balanced. Okay, so head back down into here, it has a 2- charge. We do the same crossing technique, cross the charges. Notice now that this bracket shows up on the outside. When we were counting atoms from earlier, we could see that the number on the outside indicated kind of how many groups of that polyatomic ion that we had. So in this case, when I cross, I'm only getting a 1, and so it's not really changing anything. I don't really need the brackets if it's just a 1, but if that number was a 2 or 3, then I'd have to keep the brackets and keep the number that's outside the bracket there. The 2 is going to cross over with the sodium, combine them together, I get Na2SO4. So the name for this ionic compound, in this case the polyatomic compound, would be sodium sulfate. So notice the ending doesn't change to IDE, it stays exactly the way it is. Now, so to name them, the name is simply a combination of the name of the metal and the name of the polyatomic ion. It doesn't change the ending at all. So, we obviously can use this same thing if it's a metal and a group of nonmetals. We can also use this with transition metals as well to see what we get. So, I'd like for you to try this one out, lead-4 carbonate, and see what you end up with. So, come up with the symbol for it, the charge, and then cross them, reduce if you can, see how you can make out. So pause the video and give it a try. Alright, so let's see how you made out. So lead 4 tells us that Pb has a 2+ charge, carbonate a 2- charge. If I keep going with this and cross my charges, now what I can see here is that I have the 4 coming over. Notice now that this value is not a 1 anymore, which means that that bracket's going to stay, because I have 4 groups of carbonate. And then the 2 is going to go over with the lead, so it looks like I have Pb2CO3 and then a 4 on the outside. And remember we talked about reducing things from before? So I have a 2 and a 4 here. So I need to figure out, okay, how can I reduce this down? Well, they both evenly go into 2. So I'm going to divide by 2. And now what I'm getting out of this is I'm getting Pb1CO3 Drop the 1. So it just at the end of the day, get PbCO3, and then there's 2 on the outside of the bracket. So we can use transition metals the exact same way and go through and solve these things too. So, as an exit question, we spent the first couple of lessons going through ionic compounds and polyatomic compounds. So the question is, what is the difference between an ionic compound like NaCl and a polyatomic compound like H2SO4? How can you tell the difference just by looking at what's there at the symbols, maybe as well as the words? So pause the video, give it a try, and come back when you're ready. Alright, so difference between ionic compounds and polyatomic compounds. Well, an ionic compound is a metal and a nonmetal. 1 and 1, it's singular in that sense. Whereas a polyatomic compound, polyatomic compound is a metal, for the most part, mixed with a group of nonmetals. So, big difference there. Group of nonmetals, whereas this one is just single. Okay, both of these realistically are ionic compounds. This one kind of takes that mono ionic compound, whereas this one is poly, just meaning many. So how can you tell the difference by looking at the symbols? Well, if we have multiple symbols, like SO4, then I know that I'm taking a look at a polyatomic. If I take a look at something like NaCl, it's just single for the metal, so I know that I'm not dealing with a group of nonmetals. If I had words, how could I tell the difference? Well, ionic compounds always have this "-ide" ending, whereas polyatomic compounds tend to have endings that are "-ate" or "-ite." Okay, so their endings stay the same. So, going through this, it's very similar to ionic compounds, just the next step, which means that you're also ready for the next worksheet. So if you have any questions, let me know.